Thank you so much, John. We do have time for questions. We have 9 more minutes for questions. So if anybody has some, go ahead and post them in the chat now. John is also an avid gardener, so if you have any gardening questions, this is your chance.
I can do this chance too.
Yes. So Ken already had a question. Ken said, speaking of the pandemic, anecdotally, it seems like wildlife is returning to urban and suburban areas with reduced human traffic. Did the quickness of that response surprise biologists or not?
You know, I've been listening to some of the work that's been done with bears moving into some of the areas in the West, particularly in the Fort Davis area, and the answer is no. The reason they've moved into those areas pretty quickly is humans are not chasing them out. We're still leaving the garbage.
Good point.
Yeah, and that's why they're moving in. We're just not chasing them out anymore. They're always there.
Right, so we're just noticing them more.
We're just noticing them more.
All right. Oh, here's a great question. Do you support increasing bamboo farms as a substitute for many things that we need wood for? Is bamboo an actual sustainable product?
From what I understand, bamboo is an excellent product to be able to do a lot. It's quick growing, it is renewable, it stores a lot of carbon. The difficulty is it does require some water. And so there's not going to be as many places around the world we're going to be able to use it and grow it, but it's still where you can. It's the same as us moving into hemp, right? Well, if Lubbock is eventually going to run out enough water to grow cotton. We know that, and the farmers I work with are already thinking about that.
Right. Yeah, we're not going to be growing bamboo here in Lubbock, that's for sure.
No, right. But we can grow hemp.
Yes. So Chuck has a question. He says, can you reflect on Lubbock's phenological advancement of plants, insects, and birds, but how the date of the last killing frost is not really being much affected? So it raises the risk of reproduction and seed production. So in other words, spring is coming earlier, and we see this all across the whole US because I look at the climate data, but the last date in fall isn't changing much. So our growing season is getting much longer, especially at the beginning. It's changing twice as fast as the end.
Right.
So how does that affect the advancement of plants, insect, birds, and reproduction and seed production?
So Chuck, what I know of talking, particularly from the phenological perspective, Catherine's right. The plants are cued in to when warm temperatures start for bud break. Insects are also keyed in to when flowers are produced. So, but if the last killing frost occurs and hasn't changed, we haven't experienced yet, because I still think we're still in this whole transition process of what spring means. I haven't seen any data that shows bees and whether they're domestic or endemic are influenced by that change in spring. However, what I have noticed, if you've been driving around Lubbock, the crepe myrtles of the last couple of years have looked terrible. They're all dead and they're all dying. And the reason is we have such harder transitions in the fall and too many killing frosts in the spring, and they're not going to survive here.
So it isn't just the long-term change in temperature, it's the variability that affects them too.
It's the variability of the temperature of those plants. What we don't know is what's the response of things like bees and native bees to those changes in variability.
Well, that actually relates directly to Stuart's question, which is, given that pollen is the protein source for honeybees, does the heat-induced loss of vitality on pollen negatively affect bee nutrition?
You bet it does. In fact, that pollen won't even come out of the anther. Those anthers will just dehiss and fall off.
Oh my!
So you're decreasing the amount of pollen production by those plants substantially. I mean, interestingly enough, I haven't done it as much. One of the things I was doing for quite a while was breeding daylilies, and I go out in my backyard and take my crosses and break off my anthers and pollinate my daylilies. But I've had to go out earlier and earlier because my pollen's not viable. Later, where when I first started it here in Lubbock, I was. But so there's all that dynamic that we don't realize. And again, it's all this small scale stuff that's having these major ecological consequences. We don't know globally what the decrease in pollen production is going to be. Now, interestingly enough, you can bet it's not going to be on hay fever or ragweed or on juniper pollen, right? It's going to be on the things that we require to keep us alive.
Yes, because those are actually getting worse. Ragweed is getting worse.
That's right.
Yeah. All right, so Beatrice had a good question, and this actually relates to our May Science by the Glass. So back in May, I talked about how the pandemic affected our emissions, and I talked about how it's reduced our carbon emissions, but it also reduced nitrogen emissions. And in fact, because you can measure nitrogen emissions from satellite, those were the first things that people saw going down. There were massive reductions in nitrogen, first of all, over China, then over Italy, and then over the United States as basically people stopped driving. So she's asking, can we see the impact of that reflected, for example, in the nitrogen deposition that we're experiencing, like in Big Bend?
I would assume that that would be the case. The CastNet system, in terms of organizing that data, is always like a half a year behind. So I'm hoping by the time we see the 2020 data, we'll begin to see that signature come down. For sure, any decrease in fossil fuel use is going to decrease nitrogen deposition.
Mm-hmm. Yes. And Cornelia remarks related to this pandemic, she says, it's disappointing that we see the hottest temperatures we've experienced here in Lubbock when we have less emissions. And the issue there, of course, is our carbon emissions build up over decades. It's kind of like you smoke a pack of cigarettes every day for decades, and the lung damage occurs due to the buildup, even though you could have, a severe coughing fit at a certain time. But there's a new study actually that's just coming out, I think tomorrow or maybe the next day, that talks about the Siberian heat wave that we just had. And I don't know if you've been following the news, but in some places in Siberia, it was hotter. It was more than 100 degrees Fahrenheit in Siberia. And there's been a new study showing that without human-induced climate change, that type of heat wave in Siberia would be virtually impossible. It had no chance of occurring without humans. So, John, you've talked about Big Bend, you've talked about the US, but if you could just reflect a bit on the polar regions that have very unique ecosystems, and they're being pushed so much further. What do you think of the heat wave in Siberia? What impact will that have on the ecosystems?
So those ecosystems are all based on permafrost. And so the warmer it is, the faster the permafrost is going to start warming up. Then microbial activity is going to deal with that carbon and the CO2 emissions and methane emissions. So it's going to be an increase in the amount of CO2 from those soils and methane as a consequence of warmer temperatures. I mean, again, there has to be moisture, but if there's moisture, the microbes are going to decompose that material rather than being frozen in place. So it's a negative event by having that kind of heat wave. You bet. You want that stuff to remain frozen. Mm-hmm.
Exactly.
And again, that's the other part of the problem too. I mean, as many of you know, we garden, Debbie and I compost. We put a lot of compost. We've lost, as I've gone around our yard the last couple months, we've lost more compost because the temperature's warmer. And once we water, the microbes are just going to keep breaking it down, breaking it down, breaking it down. There's no regulation of that process. Mm-hmm. So we're losing more carbon than we can store.
Which increases the amount of carbon in the atmosphere, which makes it even warmer.
And that's exactly right. Yes.
All right. Well, thank you so much, John. This has been absolutely fantastic. Thank you, everybody, for joining us. We have lots of people joining us, more probably than we'd even have in person. Don't forget to sign up for our email list. Mackenzie, if you could share your screen, people will see that again. Sign up for our email list. There we go. Click on that link. Follow us on social media. You can follow us on Instagram, Facebook, and Twitter. And next month in August, we are having a special guest appearance from one of our professors over in the Health Sciences Center on viruses. What type of viruses? I think you can guess. But also talking about how viruses in general relate to the environment. So don't miss our next Science by the Glass. You'll hear about it via email or social media, so sign up now. It's going to be the 18th of August on viruses. Thank you for showing up, and don't forget to check out this and other Science by the Glass events on our YouTube channel because they're all archived there. Bye.
Bye all. Don't forget to put your mask on.